Welcome to day 1 of the AIM program, Accelerated Intensive Math program. Today is just introductions and vocabulary, so not anything really complex at all, but we do want you to have a good understanding of how this program will be working before we actually get into the math stuff tomorrow or the next video whenever you watch it. So introduction to me, and then overview of the program, and then we'll talk about the tech platforms we'll be using very briefly. The main two things for today are a preview of each day's content and kind of the order and what's covered specifically on each day. And then vocabulary, kind of essential math vocabulary for any math stuff that we might do. Specialized vocabulary will be on the specific days. And then a little bit of practice for just how to read some stuff, and then advice for how to learn math well, how to improve your math abilities. Okay, so introductions first. To SolBridge, I teach at SolBridge. This program is being offered through SolBridge. I'm guessing if you're watching this video, you know exactly what SolBridge is. I guess just in case you don't, it is an international business school in South Korea. And if you're watching this, I'm guessing you are an incoming student. You will be a first semester student in a few weeks or in a month or something. Some of you might be upper year students just looking for some kind of, or current students just looking for some math review. I don't think there's anyone who's never heard of SolBridge here. It's hard for me to know exactly where the links from this program will float over the internet in the future, but I'm assuming you're all SolBridge students. So that means that you have or you will be meeting me. My name is Daniel Corks. Students just call me Mr. Corks usually. So I'm an assistant professor at SolBridge. I am also the mathematics coordinator. Why I am the person who is teaching this program. I teach the Mathematics for Business course. That's one of my main responsibilities. So if you are a first semester student at SolBridge, you will definitely do that class, and you will do it with me. Again, unless in like the far future something changes and someone else teaches it. But when I'm making this, I am definitely the one who teaches it. So this is kind of preparation for some students who maybe felt that they weren't totally ready to start that class when the semester started. This is to kind of help get them ready for that. But again, maybe you're an upper year student or something taking this. So the program itself, let's just do an overview of this. So target audience, if you're listening to this and watching this video now here with me, I am guessing that you are a person who has you've never done a math class in English before, or not any sort of serious class, so you're not familiar with listening to lectures about math in English or talking about math in English, or you are someone who has just not done a math class for quite some time. Maybe your high school, for your final few years of high school, you focused on other things and you just didn't really do much with math, and you've forgotten some things, you want a refresher. Or maybe you're someone who's kind of a bit weaker with math in the first place and just wants some more practice. If you're a person who uses a calculator kind of for everything, then the design of this program is also to help you get a little better at not needing your calculator all the time. So the goals of the program are from directly kind of who this is designed for. So being able to listen to lectures in English and talk about math in English is one of our goals. Second one is that you're able to do this sort of core arithmetic and things that we'll see in this program quickly without having to kind of pause and remember what the process is. It should just be quick, automatic. I don't know if the microphone heard my snapping or not. And that you can do things without a calculator. Calculators are nice for very large calculations, but in an exam situation, we don't always have a calculator available. Or just quick arithmetic. If you learn to do this stuff quickly, you can just, your brain will do it almost automatically in the background. Pulling out a calculator takes time. It's slow. If you're in the middle of a conversation with people talking about numbers, by the time you've pulled out a calculator, the conversation's moved on or you've forgotten the numbers. You know, if you're doing a longer or harder question, sure, calculator to verify things, but basic operations, you shouldn't need it. Like the ones here. If you look at these operations and you say, oh, let me grab my calculator to figure out what those are, then I hope that you don't do that and you will learn to not do that through this program. So 1,000, 58, 168, 5. Like just looking at those, it's just instant or nearly instant in your brain to figure those out. Okay, formats for this program. There are this introduction video and then 9 math topics, so 10 days total, aside from this introduction one. There's a video for each of those topics, and there are a bunch of review questions in the textbook. The videos are about 30-35 minutes. Review questions depends on how many of them you want to do or feel you need to do, but 30 to 60 minutes. And then a quiz to try out afterward. The quizzes are going to be very short, just 5 questions, and you should be able to do it in 5 minutes too. So make sure you're well practiced before you try those quizzes. You only get 1 attempt at the quizzes also. Right, so 2 weeks, since there are 10 videos, you'll like 5 each week or something. Sorry, yes, 5, 1 per day for 2 weeks, weekdays. That should take you about 2 weeks. Maybe you spend more time, maybe you do it faster, you skip some topics, whatever, that's up to you. But I recommend not doing more than 1 topic per day. You know, give your brain some time to absorb the information. There will be a final test at the end to see how well you've acquired all of this. All right, textbooks. There are 3 different textbooks that we will be using. Mostly it's the intermediate algebra 2nd edition textbook, the one you see at the bottom there, but I will have some days where I pull questions or examples from these other ones, or I recommend practice exercises from these other ones. They're all written by the same people, it's the same format, they're all very similar. They are also all free. They are open textbooks. You can just go to the website that's right there and just download a PDF or view them directly on the website. And they're good textbooks too. It's not like free so they're bad or something. We're using them because I quite like them. I use these in my regular classes as well. So very convenient and free. There are 3 of them, and I know that's a bit annoying and confusing, but every slide, every time I give practice questions, is very clearly labeled which textbook everything is from. So pay attention to that and you'll be fine. So in the textbooks, you can see here, this is actually the first questions that we'll do in the next video. So I will do one of the examples that's in the textbook, and I'll give sort of a summary explanation of kind of the main concepts. If you want more detail and more explanation, you can always just look at those examples in the textbook, and they have a very detailed explanation here you can read. So we'll do the example with careful explanation from me, and then there are 2 kind of practice ones, I will do one of them, just so you can see kind of how it works at a natural speed. And then you get to do the other one. I will pause the video and you'll see a little spinning thing like, so that little pause, and then you actually pause the video for real and do the question yourself, and then come back, and then I will show you what the answer was. So that's the pattern. So one example, and then two practice ones, one for me, one for you, and then we go on to the next topic. The practice exercises just at the back of, excuse me, just at the end of that section in the textbook. So for example, section 3.1, just the last few pages of that section, you'll see all the practice exercises. There are lots. That's one thing I really like about this textbook series, is there are tons and tons of practice exercises for you to go through, not just like 2 or 3 or something. And all the textbook examples and those try it questions that I will do during the videos, and also half of the practice exercises at the back all have answers at the very back of the textbook on the final few pages. So you can check your work. It's math, you can check your work normally, but you can also verify by flipping to the back of the book and see if it's correct. So good things to be aware of for our textbook. Right, so there they are. Next topic, the platforms. We will be using Google Classroom, YouTube, and Google Forms. You are watching this video through YouTube. I believe that's how I've set this up. Google Classroom is sort of our hub for the extra information, and that's where you find the links to all the videos and the quizzes and the tests and everything. So that's our hub sort of website for this program. You watch the videos on YouTube, do the practice exercises, and the quizzes are through Google Forms, but those are all just linked directly from the Google Classroom page. So getting access to that Google Classroom page is obviously important. Again, you've probably done this already, but just in case you are somehow watching this first video and you don't have access, you haven't done that yet, this video is the first thing you're seeing. It's not hard to join, so just have a Google account. You probably have one already. Access Google Classroom, just classroom.google.com, or you can download the app for whatever smartphone you have. And then in the corner, when you actually access Google Classroom and you're signed in to your account, you will see here just a little plus thing. Just click on that and then join class. And it will ask you to put in a code, a 7-letter code. I'm not putting it in the slide here because I'm future-proofing this and might have to change the code at some point. But the code will be in the description of this video on YouTube, and also however you heard about this program, however it was marketed to you, the join code should be there as well for you to use. So that's how to join. And when you join, you will see this. This is so you'll see the hub, kind of some just written text explanations of everything up here, and then here's the day 1 video, here's the day 2 video, here's the day 2 quiz, etc. It's just there. It's all there. Very easy to use. Okay. Quick side note here, just in case you are in China physically right now. If you're a Chinese student and you're not in China, then that's fine. You can make a Google account easily enough. But in case you are in China and firewall, things blocked, whatever, You are going to need a Google account to access the Google Classroom page. That's unavoidable. So ask a friend or a classmate or me or whoever for help. They can make a new Google account for you and then just give you the information. I'm assuming you have a VPN because you're watching this video and it's on YouTube. So with that, then someone can make a new account. Hot tip here, usually when you make a Google account, a new account these days, it requires a phone number. To avoid that, ask your friend or classmate or whoever to use the Gmail app on their smartphone and make a new account through that, and it will not require a phone number. And then they will just give you the login information for that account, and then you change the password, and then you now have a Google account that you can use in China through a VPN. So that part is unavoidable. Sorry about that, but that's how you can get around it. You'll need a friend to help, or contact me or whoever to just, anyone outside China can make a new account and give you the information. Okay, that's the background. That's all the kind of administrative stuff. So let's talk about the actual stuff we'll be learning. I've split this up into kind of 3 different parts. Each part has 3 different days. And then at the end, there's a final, each day has a quiz, as I mentioned, and then at the end, there's a final test and a survey I would like you to do as well to tell me if you enjoyed the program, was it helpful, not helpful, whatever. Please do that survey when you finish. Okay, so part 1, fractions and decimals, long multiplication and division. You might notice already that this math content is, not like super difficult. This is kind of middle school, early high school level stuff, which I'm aware of course. You have learned all this stuff before, of course. Maybe you've forgotten some things, or maybe just when you do this stuff, it's kind of slow. The goal of this program is that you can do this stuff quickly, easily, almost like not 100% automatically, but sort of like the subconscious part of your brain can just work through this very quickly. That's the goal with all of this. So quick and easy and accurate and no calculator. That's the goal here. I don't think I will be teaching you anything brand new that you've never seen before. Maybe it's just been a while and you're kind of rusty. That's the intent. Okay, so fractions and decimals, adding, multiplying, dividing them, simplifying complex fractions like this thing here, and converting from decimals to fractions. That's day number 2. All right, day number 3 is long multiplication. So where you have numbers like this, 3, 5, 4 times 4, 3, 8, like this, and just this and this, and then you add, and then that. Long multiplication, again, without our calculator, just being able to do this by hand relatively quickly and accurately. So practice with that. Day 3 is the same thing, but long division. So like this. So this thing goes into this part this many times, and then this, and we subtract and we get this and bring down the number. This thing, this is long division. So practice doing long division is day number 4. And that's part 1. Part 2 is about sort of factors and expanding factoring with brackets. So first, some kind of just tricks or shortcuts to recognize factors. So if we take this number, can we divide it by 2, by 3, by 6, by 9? We don't need to actually do the division. We can just notice some patterns about the number and then figure that out very quickly. So how to do that, how to factor a number into its prime factors, and I'll explain exactly what all that is in the day 5 video here. How to use the prime factors to easily find the least common multiple between two numbers or the greatest common factor between two numbers. That's 5. 6 is expanding. So how to do kind of this multiplying, basically. We have some brackets and then a thing outside the brackets. How do we multiply in sort of larger cases like this? Day 7 is factoring. So just some simple factoring, finding basically a greatest common factor. So what's common to all of these 3 terms and just taking that part out. Excuse me. That's first, and then also how we can use factors and factoring numbers to take something like this and be able to just do it very quickly in our heads and sort of notice some patterns so that we don't have to do kind of long subtraction and write it all out. We can just notice, okay, I kind of see some patterns there. Okay, I got the answer. So being able to just quickly do that stuff. And same with multiplication. It works for adding, subtracting, multiplying, dividing, all that stuff. Factoring tricks. Part 3 is about sort of equations, functions. So first, just solving linear equations, moving things from kind of one side of the equal sign to the other side and this, and then figuring out, okay, q is equal to this, x is equal to that. So some just basic practice with that stuff, with fractions, with decimals, and then some kind of special cases where it doesn't, you don't just get a simple basic answer, you have some other things happening, and how we talk about that stuff. Day 9 is about rearranging formulas. So an equation, but we have multiple parts, sorry, multiple variables. So we can't just solve and say x equals this or y equals that. So just kind of rearranging. That says solve for C. That's a mistake. That should say for F. The rest of these are right. So these are all actual sample problems that we will be covering in these days. So if I have this thing and I want to rearrange it to be h equals something, just how do we do that? Do some practice with that. And then more complex things where just everything is a variable. We just got to move all the parts around. That's day 9, and 10 is function notation. So this kind of thing, like f of -2 or g of x plus 2, and then we kind of put that in here, and then what's the result of this and evaluating that. And then a few word problems kind of based on those. That's day number 10. Okay, so that's an overview of what all the topics are. If there's 1 or 2 of those where you say, oh, that's really easy for me, I know that very well, I don't need practice, and also you know how to talk about it in English, great. If you don't watch that video because you're confident in that area, fine. I won't be offended. But this way you can kind of see which topics are ones you want to do and which ones maybe you don't think you need to do. Okay, vocabulary. This is the other big thing. Lots of words. If you've never done a math class in English or never talked about math in English before, this is kind of going to be a lot. I will review a bunch of this stuff in the later days. I will talk about math a lot, so you'll hear me talk about this a lot, and it will help you learn it. But at first, this is just might feel like a lot of information. So first, just our operators here. So this is addition. Concept is sort of adding, like the noun version. If we say it as a verb, then that's add. We add 2 numbers. And If we have an equation, though, or something like this, we'd read this as a plus b. So the symbol we read as plus, not add. So that one's not so hard. You guys probably know that one. Next one, subtraction and subtract and minus for the symbol. Next one, multiplication and multiply. The symbol we would read as a multiplied by b, or the shorter version that's very common, a times b. A times b means multiplication. That's usually how people will read that. The last one here is dividing. So division and divide is the verb, and we just read this as a divided by b. Okay, so these 4 core operations, we actually have 3 different words, and case 4, just for this one operation. A bunch of different parts to learn, but all essential to know. Okay, so those are the basics. Next, when we do those operations, we have special names for the results. So if we do a plus b, if it's equal to c, then c is a sum. So the result of adding 2 numbers is a sum. If we subtract 2 numbers, the result is a difference. If we multiply 2 numbers, the result is a product. And if we divide 2 numbers, a divided by b, then c is a quotient. Quotient. Sum, difference, product, and quotient. We definitely use these words a lot. These ones also. Please make sure you're familiar with these. All right, so how to kind of read some things, some other symbols here. There is a difference between a negative sign and minus for subtraction. So this here, for example, is negative a. It's not minus a. So this is negative a minus b equals negative c. So please note the difference between negative and minus. Minus is an operation. Negative is just about the individual number. Next, these things are parentheses. Parentheses. In American English, you will hear people often call these brackets. I might do that sometimes as well. I'm from Canada, but we kind of we would use both terms. I prefer parentheses because it's more clear. So that's what I will try to say. And the other one, these square ones, would more properly be called brackets. In American English, again, they would call these square brackets, but I think the rest of the world just calls them brackets. And the original ones here, the curved ones, parentheses. If when we read equations, often, we don't actually say parentheses, but if we need to, if it was required for clarity or whatever, then we'd say like in parentheses, comma, whatever, a plus b, or in brackets, a plus b. If we need to talk about them, that's how we. Not always necessary though. All right, I hope you're like pausing and taking notes as we go through this. I'm not going to just like wait because that's kind of a waste of time. All right, so being equal or not equal. So just a equals b is how we read this. A equals b. I know some other languages would just use the be verb, like a is b, but we don't do it that way in English. So a equals b and a does not equal b is how we'd read this other one for non-equivalence. A does not equal b. or is not equal to b. I should have included those. So this could also be a is equal to b. This is another way of reading that. Both are fine. Right, so next one's, this here is a less than sign or a less than operator. So we'd read this as a is less than b. And then the other one here, a is less than or equal to b. So it's rather long. A is less than or equal to b. 6 words just for that one symbol. But that's how we say it. That's how we read it. And the opposite for the other one. So a is greater than b, and also a is greater than or equal to b. You might want to say like a is smaller than b, or a is bigger than b, or a is larger than b. Those all make sense, but those are not the standard terms. Whenever you hear people talk about math, they specifically use less than and greater than. Those are the standard terms. So I hope you're familiar with those, and when you're talking about math, please try to use those ones. It'll be easier for everyone to understand. All right, got a few more of these. 3 more slides of these. So equations. So if we have something like this, so 3a equals b, sorry, 3a equals 5 is how we read this. A is or the whole thing rather, first is an equation because we have 2 sides that are equal to each other. Inside that, we have a, which is a variable. We don't know what a is equal to. I know we can solve this very easily, but in general, we don't know. The variable could be anything. 3, the number that is in front of a and kind of attached to it, being multiplied by a, we call a coefficient. And any other number that is not like attached to a variable, it's just sort of floating around on its own, that is a constant, because it is constant. It does not change. Variables change. So those are the 3 parts in there. We need to know those 3 terms. Something like this, if we had 3a is less than 5, or 3a is greater than or equal to 5, this is called an inequality. I know this is equation, so you might say, well, inequation, that like perfectly logical, but that's not the name. That's not the name people use. So inequality. And kind of the same token, you might say, well, inequality, so this thing should be called an equality. But again, the logic is the perfect logic, but nobody actually says that. So equation and inequality. All right, so fractions and decimals, the topic for the next day, but we need to know how to talk about them. If we have a fraction, basically we could just read it like this: a over b. Just very kind of like visual description. It is over, it is above the other one. So a over b. Another way we can read this, if we have specific numbers, so here, 5 over 7. You will sometimes, not usually, but sometimes hear people say something like this: 5/7. So where 5 is the cardinal number, like 1, 2, 3, 4, 5, and 7, or the number on the bottom, is the ordinal number, like 1st, 2nd, 3rd, 4th, 5th. This is not so common. It's usually just like this, maybe people might say as 1/3, or like this 3/4. Just a few special cases for small numbers. Most of the time, people will just say something over something. That's standard for fractions. Okay, so decimals here. This, we read the decimal point here as just 0.8. The dot, the name for the dot is a decimal, but we don't read the number like that. We don't say 0.8. It's 0.8. If it does start with a 0, then sometimes people will, excuse me, people will leave off the word 0 and just say 0.8. That's common as well, sort of a shorter way, but standard way 0.8. If we have something longer, like we have down here, this we would read as, so the number in front, 45, standard way of reading that. So 45 point, and then the ones after you just read individually. So 45.023. We would not read this as 45.023. So we don't make like groups with these numbers when reading them. It's just 1, 1, 1, 1, 1 for everything after the decimal. So 45.023. Right, okay, so fractions, decimals, and one more slide here, exponents. We aren't really going to talk about exponents much in this program, but it is definitely a thing that is important to know how to talk about and how to listen to. So if we have an equation like this, a to the exponent b equals c. So a is the base number. B is the exponent. That's the main word to know. And then C, which is the result of the base and the exponent together, is a power. Fun name there. So base, exponent, and power. When we read these things, this would be a squared. A squared. This is a, or let's go down to the, more generally, a to the exponent n here is how we would read this. So a to the exponent n. Long, I know, Korean, for example, it's just this one very short word to talk about that, but instead here in English we have 3 to the exponent n. Or you can read this as the nth power of a. Again, using this term power, sort of meaning the result. Nth power of a. There are a lot of people who will say this third thing here, a to the power n, which I'm going to say is technically inaccurate because n is the exponent, it's not the power. But very frequent, like if you listen to any sort of like American English math teachers or whatever, they're probably going to say it like that. I don't like it. I'm not going to say it that way, but you will hear a lot of people say it that as well. So 3 ways of talking about exponents in general. For 2 special cases though, if our exponent is a 2 or a 3, we have these special terms squared and cubed. So a squared or a cubed. Area of a square, if one side was a, then a times a would give us the area. Or if we have a cube, then the volume would be coming from a times a times a to the exponent 3, whatever. So those special terms, those are very, very frequently used. You will need to be familiar with those. If you always say it as a to the exponent 2, you know, that's fine, but you need to be able to understand when people say a squared, a cubed. Right, so the other half of this are roots. So This here is a square root because, we understand that there's a little 2 there. So square root, just like we have a squared, and we have a cube root because there's a 3 here, just the kind of natural counterpart of a cubed. And then more generally, we have the nth root of a, or shorter way people would say this is just a root n, a sort of kind of imaginary comma root n, like this. So these are the ways we talk about roots. Okay, exponents and roots, again, we won't use too much in this program, but very important to be able to talk about. Okay, we did it, kind of. So here's some practice. Here's our fun word cloud. All the terms I was just using are here, so hopefully you're able to look at these and remember what each of these things mean. If you want, you can kind of pause the video now and just test yourself, see if you remember what all these concepts are. Go ahead, like. Okay, and the kind of main practice that I have intended for this is this here. Now I will go away, show the little floating pause thing. I want you to look at each of these and try to read them out loud. How do we say each of these things in English? If this is your first time having a math class in English, then please do that practice. If you already know, then okay, fine. But if all that vocabulary is new for you, then please do this practice here. So pause the video, try to read them all out, and then I'll come back and I will read them for you, and you can see if you got them right. All right, I hope you actually pause the video and actually try reading these out loud for yourself. Doing the practice is very important. So first one here would be 1/2 times, if I want to read the brackets, I guess I could read them. So 1/2 times, in brackets, x plus 4 equals 3/4. Next one. So kind of pausing and where you're pausing would help clarify which things are sort of in the brackets or on top or below or whatever. 7u minus 1/4 minus 1 equals 4u plus 8/5. Next one. 0.05n plus 0.1 times n plus 7 equals 3.55. Next one. 4/5 times h minus 2/3 times h minus 9 is greater than or equal to 1/15 times 2h plus 90. Next one. 8p cubed minus 3 all to the exponent 2, or all squared. I guess we don't need the all part there, but just to make it very clear, like kind of saying these brackets out loud, or parentheses out loud, or I could say so open parentheses 8p cubed minus 3 close parentheses squared. Saying it with all sounds a little better, but if we're being super technical, we could say it that way. Next one. 36 to the exponent negative 1/2. Next one. Square root of m to the exponent 13. And fifth root of u to the exponent 7. Okay, so that's how we say each of these. The exponent ones I know, like, are we reading like this, or are we reading like fifth root of u and then the 7 outside? Again, sort of where you're pausing as you're saying it would be sort of the clarification, but we don't do math by dictation. We see it, so we're always writing it or looking at it as we're talking about it. So that kind of fine detail isn't super critical, but just kind of the basic names for the parts and the various operations. That's what I want you to be able to say. Okay, so there's the practice. We'll close up with our last thing is a bit of advice. Again, in case you are the kind of person who is saying, well, math has been really hard for me for a long time, you're concerned, whatever. So my advice for you is you should always be asking yourself if you actually understand how to solve a certain kind of problem. So what I very often see students do is they are listening to my lectures and then they say, oh, I understand everything, like during the lecture. And then they say, okay, I'm done. I understand it. I know everything. I'm ready for the test. That does not work. That is step one. Of course, it feels like it makes sense while you're watching someone else do all the work and explain it to you. But the next step would be trying to solve some sort of, exercises, practice problems, whatever, on your own outside of class time, but while referring to kind of notes or examples from class, like, well, here's how they did this one in the lecture. Here's a similar one. I'm going to try to use the same method. So if you can do that, that's the next step, but that's not enough. Third step is you should be able to solve the problems without help. So if you did it one day with help and kind of looking at your notes, then wait a day, come back to it the next day and try to do it again without looking at your notes, just on your own, just using what you know, your own brain. So solving problems without help, that's a minimum. If you can't do that, then you have not learned the material. So kind of keep asking yourself, can I do this? Can I solve it on my own without any help? And keep doing practice and reviewing or whatever until you get to that point. Ideally, you can do that, but quickly. And you don't have to kind of pause and struggle and really think deeply through the problem. You can just kind of go through it. If it's an easier problem, that it won't take you that long. That means you're very familiar. And again, the automatic kind of parts of your brain have taken over because you are that familiar and practiced. That's the ultimate goal. Hopefully you can do that for all the problems in this program we are doing. Definitely, you should be able to do this. It's very kind of core math skills we should all be able to do quickly. But at the minimum, being able to solve problems on your own without looking up examples or whatever. Keep doing practice until you get to at least that point. So just math is a practical skill. It's not a memorization skill. Like if you're learning how to play the piano, it doesn't count if you like listen to someone else play the piano and say, oh yeah, that makes sense to me. You have to actually do it yourself. You have to prove you can show people you can do it on your own. Only then can you say for real that you know how to do that. So it's not memorize this stuff. It's actually do the examples, do the practice on your own. That's the way to think about it. If you have that kind of mindset, then it should be easy for you to know if you understand it or not, and then you know what you need to practice. All right, wrapping up. So there's our little word cloud again. I introduced SolBridge, in case any of you don't know, and myself, give an overview of the program, our goals, formats, where to get the textbooks, tech platforms, and perhaps some tech problems, how to join the classroom page, all that stuff. And maybe you're in China, how to work around that. Preview of the content and what we will be covering each day from this point, and core vocabulary that we will be needing all the time. You should be familiar with all of those terms. And then get a bit of practice, some advice, and that's it. Tomorrow's class, as I mentioned, or the next video, whenever you watch it, is about fractions primarily. So just working with fractions. Again, you've done this before, but quickly, easily, naturally, that's the goal. The vocabulary that I will talk about in the next day is here on the right side of the screen. You can kind of preview that stuff now if you want, or just wait till the next video and I'll explain it in detail there. Okay, well, that's it for this one. Hopefully this was helpful for you and gave you a good understanding of what this program is and how everything is going to work. I will see you in the next video whenever you decide to watch it. 5 minutes or tomorrow or whatever. See you then.